let's get started. So for the first two parts of this lesson on Aurora, we will be talking about why Aurora happens, but to set that up, we're going to talk about the night sky, why night happens, and also how do seasons happen. So to start off, we're gonna just follow along with part one. You can either watch this video or you could read the text that's provided in the lesson or sort of look at both together. So let's start. Our planet, Earth, is not stationary in space. It moves, it spins. We have things spinning around us that are both natural or artificial, like satellites. So Earth makes a complete spin or rotation around an imaginary line called the axis. And this is shown as the pink line in image 1. So you have Earth that's rotating in space around this imaginary axis. And this axis runs through the North and South Pole. And so this rotation happens every day, which actually sets the length of our days to being 24 hours or close to 24 hours. And at different times during this daily rotation, parts of Earth are either facing the sun or facing away from the sun. So just as an example, while the state of Virginia is facing the sun, that's day, right? But at that same time, the country of Indonesia is facing away from the sun, and that's night, right? So while it's daytime in Virginia, it's nighttime in Indonesia and other places as well. So this length of the full day, which includes daylight and the parts of the day where there's daylight and the parts of the day that are night, this is roughly 24 hours all year long. But you may have noticed that the length of night when it's dark is shorter during the summer and night is longer during the winter. So why does that happen? Well, this happens again due to the Earth being on this, rotating on this axis. The axis is actually tilted though, as you can see in image 2. And Earth makes a larger spin, not only around its own axis, but around the sun as well. And so that's nicely demonstrated in image 2. And this would be a good spot to pause this video and take a look at both image 1 and image 2. So you might have some questions here. Why is Earth's axis tilted? Why is it rotating along this axis that is at a somewhat strange angle, like Earth has been knocked on its side? Well, this is actually because Earth's axis was knocked on its side. And this happened early on in Earth's history, where a Mars-sized planet called Theia crashed into Earth. Nothing was living at this time, but it did cause huge changes in our planet, right? Earth was essentially cracked open by this Mars-sized planet crashing into Earth. You can think of that as sort of like peeled open, and rocks and lava were blasted into space from Earth. And from remnants of that Mars-sized planet impacting Earth. And those bits that used to be part of Earth and this Mars-sized planet were floating around in space and eventually grouped together to form the moon. There's a really good article and a video by the Natural History Museum of London. If you want to check that out, feel free to pause this video and look at that article or watch that video. So how exactly does a tilted axis and Earth spin around the sun cause days and nights to be different lengths throughout the year. Well, this tilted axis makes it so that parts of Earth are slightly farther from the sun, depending on where Earth is in its journey, this yearly journey around the sun. So you can see in image 1 that the South Pole, or the bottom of, we can think of it as like the bottom of the planet, at least in that image, is closer to the sun. And the North Pole at the top is farther from the sun, slightly farther from the sun. But the South Pole is not always the closest pole to the sun. So because Earth makes this larger spin around the sun, the North Pole is closest to the sun, and the South Pole is farthest from the sun in June, or we can generally think of in the summer. So this results in more daylight and warmer temperatures in the top half of the planet, the northern hemisphere, during the summer, or in this case, we can just think of June, to be consistent with the images that you're looking at. And this Earth-Sun configuration is called the June solstice. So this is in the northern hemisphere. This is when the amount of daylight is at its maximum throughout the year. And then in the southern hemisphere, the bottom part of the bottom half of our planet, this is when the length of daylight is actually short, as short as it will be in that year period. And so when it's summer in the northern hemisphere, it's winter in the southern hemisphere, because it's darker and it's colder during that time of the year. But then if we look at the other side of that image too, around and during the December solstice, which is the time period where there is the most amount of nighttime in the northern hemisphere, and the most amount of daytime in the southern hemisphere. The situation is different, right? So while it is, just think of December, while it is winter in the northern hemisphere, so winter in Virginia, it's actually summer in the southern hemisphere. And so this is how seasons are set up. And this is important context for thinking about aurora, which is something that we see in the night sky and often observe more during the winter, either in the northern hemisphere or in the southern hemisphere, just because there is more nighttime in the winter. So let's move to part 2. If you feel like you need to take a break, go ahead and pause there. Feel free to check out any of those resources that we link to in the lesson. And if you're ready to start part 2, you can just continue with this recording. So let's talk about aurora. And to do that first, we have to talk about stuff that comes to Earth from the sun. So remember, our planet is and us being on our planet, we are rotating around the sun. And the sun sends a lot of stuff to Earth. So we get visible light from the sun. We also know that we get heat from the sun as well. And there are other types of light too that come from the sun that are not visible, like ultraviolet and infrared. These are other types of light that you're welcome to check out. Either pause me or you can explore that on your own time after this workshop. So the sun also sends really teeny tiny particles that you cannot see with your eye, called electrons. Electrons coming from the sun interact with our atmosphere, which is essentially just the space between Earth's surface where we live and walk and space. So the atmosphere is made up of gases as well as teeny tiny pieces of water, and that separates Earth's surface from space. So these electrons are coming in and they're interacting with gases in the atmosphere. This is ultimately what the process that creates aurora. Now, most of those tiny particles, those electrons, are blocked by Earth's magnetic field. So similar to magnets that you might have on your refrigerator, or my 3-year-old son is really interested in these building blocks called magnetiles, right? Earth itself is essentially a magnet. And this magnetic field is really like a shield around our planet that keeps stuff from coming into our atmosphere. So it's this layer of defense. And you can see that in image 4. Those lines that you see around Earth, those are supposed to represent the magnetic field. And there are all sorts of really awesome facts and information about the magnetic field. So definitely explore that if you're interested in magnets and these sort of large concepts that are really important for our planet and other planets as well. And so this interaction between electrons coming from the sun and our atmosphere produce energy in the form of light. And this is what aurora is. So that light that we see is actually just a response or sort of an outcome of those electrons hitting and interacting with gases in our atmosphere. Typically, this light is produced somewhere between 50 and 300 miles above Earth's surface. And there's a really, really great video that demonstrates the electrons and their interaction with our atmosphere and the magnetic field to ultimately produce aurora in certain parts that we can see in certain parts of our planet. This is actually put together by a tourism company called Visit Norway. And the reason why they put this video together is because Norway is a place where you can see aurora in the night sky, and we'll follow up on that in a little bit. So what does aurora look like? Mostly it's waves of green light, like you can see in images 5 and 6, but this really depends on the types of gases that are present in the atmosphere, where these electrons are really sneaking in, typically close to the North Pole and the South Pole, sneaking in where the magnetic field essentially pulls these electrons into that space at the North Pole or around the North Pole and at the South Pole. You can see this really awesome video that was taken by astronauts on the International Space Station, where as the space station is orbiting around Earth, they picked up this really awesome aurora that was happening. I'm not sure if it was the South Pole or the North Pole, but maybe you'll be able to figure that out on your own if you watch the video. But this is something that we can see, right, both from space, but more often, people like us who are not astronauts or not currently astronauts, we typically see this from Earth's surface, looking up instead of from a space station looking down. And these waves of colorful light are only visible to the eye on cloudless or nearly cloudless nights because they are not very bright. And they're not visible everywhere, as I mentioned before, just in special places that are not protected as much by Earth's magnetic field. And that happens to be, again, at or around the North Pole and at and around the South Pole. And so around the North Pole, these lights are called Aurora Borealis, or Northern Lights. And around the South Pole, they're called Aurora Australis, or Southern Lights. And there's a really, really great video that's linked in the lesson of Aurora Australis as seen at the South Pole Research Station in Antarctica. It is very rare that aurora creeps down, or auroras are visible beyond these polar or near polar regions, either around the South Pole or North Pole or the South Pole. But sometimes they do. And image 7 is showing where aurora was visible in Maryland. And this was actually, I think as of 2019, no, maybe 2020, what year is it? 2020, last year. Aurora was visible pretty far south. And so if you haven't learned about directions, north and south and east and west, you could also take this as an opportunity to pause me and to learn about those, what we call cardinal directions. And so the aurora that was visible in this image that we're showing you was actually red. And this again results from what types of gases in the atmosphere those electrons were encountering as they were essentially falling into our atmosphere. And so similar to weather, there are forecasts for where you can see aurora. And I've provided a link here to a map that I think is updated every 30 minutes. So you can see where aurora is likely to be seen in the night sky. And so just really cool to be able to sort of step through with you, right? Like, what is night? How do we get different lengths of daylight in night light, or absence of light at night during the year? And then to think about this really cool process of aurora and how that happens. And so now through these resources that are linked, hopefully you can take an opportunity to really just go back to what you found interesting, or what you want to learn more about. Go to these links or do some searches online and sort of do a self-guided exploration of some of the concepts that are mentioned here and shown as bold in your lesson plan. Or just every once in a while, feel free to go to that map where there's a forecast of aurora. And who knows, maybe we'll get lucky and we'll be able to see aurora in Virginia in the night sky at some point in the coming future. So we're done with the sort of environmental science lesson part of the workshop, and now Kate will take over to go through part 3 and help you all put together your craft that demonstrates aurora in the night sky.